Here we are, day 2. Okay, day 2. Okay, here's what you know. You know you can take a polynomial, you can classify it by number of terms, you can classify it by degree. Degree to me just means what's its name. And then you can tell me something about the end behavior. Up, up, down, down, up, down, or down, up, down, up. Okay, so you can tell me certain things about it, but now here's one more thing you can tell me about a polynomial. You can talk about how many times it turns. Look at this one. How many times did it turn? None. This one.
1. Twice? No.
0 or 2.
1.
Well, just look at this one. Did this turn once?
No, it's not.
Watch my hand, watch my finger, watch. Ready? Up, 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 up. It never went down, did it? There's no turns here. This is the 0 turn one. Okay, what's 2 turns?
That one, I guess.
Up, down, 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 up. Obviously, this is what?
Apparently
2 turns. This one has what?
0, I guess.
0 turns. Okay. Yes, functions do turn twice, 3, 4, 5 times, but sometimes they don't turn at all. And don't turn at all looks like this. Up, 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 and then it slows down, but it's still going up, still going up. And then it kind of turns the corner and goes right back up. This is 0 turns. Okay? It happens. And these are the kind of hard ones. Because you want them to turn, it's like you're expecting it to turn, and it never turns. Those are the hard ones. Okay, now, take a look at what it says up here about terms. The graph of a polynomial function of degree n, where n has to be equal to 1 or greater than 1, has at most blank turning points. Okay, let me throw a number at you. Instead of saying degree n, let's say degree 5. Because you guys like numbers better than letters, right? So if you have, this is a degree what? 5 polynomial, has at most blank turning points. What do you think it is? Any guesses? 1 turning point. It will only turn once. He says 1. Taylor's got 1.
At the very most.
At the very most.
Twice.
No other guesses? Guess why you have no guesses? You never learned this back in Algebra 1. Here's what it is. It is what?
1.
It is n minus 1. Now guys, if this n is what? What's n?
The degree.
5.
N is 5. Whoops. Sorry. N is 5. So you're going to say what?
4.
At most it can turn what?
4.
4 times. At the very most. Okay, which leads me to believe if I had x to the 6th, how many times can it turn?
5.
5 turns. At what?
Most.
At most. Which leads me to think, if that's what they're saying, then it could turn something else, right?
1, 2, 3, 4.
Wait. Something's coming. Ready? Keep reading. The graph of a polynomial function of odd degrees. Oh, I don't know if that's in the right spot, but odd degrees has an even number of turning points. So odd degrees.
So
That's
the
not odd.
opposite.
I'm going to change it on you. Let's make it odd.
Well,
Odd degrees, like 7, can turn what?
6 times. So it's odd.
6 at the most. So can turn what?
Even number.
Even numbers. Oh, so a 7th degree polynomial can turn 6 times at the most?
Okay.
Or what?
Or less.
No.
Or
Even
4
numbers.
Or 2.
6 go down 1 even.
4.
4 or
2.
2 or
0.
0. The pattern is it could turn 6, 4, 2, or 0. It's not going to turn negative. You can't say negative 4 turns, okay? So these are your options. But your question on your test will be this. Your test question will say, at most, what could a 7th degree polynomial turn? You're going to say
6 times.
6. You don't have to say 4 or 2 or 1. You don't have to say that. Okay? All right, keep reading. The graph of a polynomial function of even degrees has what kind of terms? Odd numbers. So watch this. X to the 8th can turn at most 7 turns.
5,
Okay.
3, 1.
Okay. Or what?
5, 3, and 1.
5, 3, 1. There it is. Got that?
Yeah.
Okay. So do you know how to classify how many turns it could have? Just do what to the highest power of x? Subtract 1 and then just go down by 2. So 7, 5, 3, 1. Or 6, 4, 2, 0. That's all you have to say. Okay? Good? Look at your next picture right here. Your job on this one is to look at your graph. Look at your graph. Determine the sign of the leading coefficient. So I want, is it going to be a positive or a negative to make it do this? And then give me the least possible degree of the polynomial. Just by looking at the picture, you can tell me this. So I'm going to say LC. What's LC? Leading coefficient, and then they want the least possible what? Degree. Okay. So these are the two things you have to tell me. So leading coefficient. First of all, does this act like a parabola or a line?
Parabola.
Up or down, down?
Down.
This is obviously a down, down. To make it go down, down, the leading coefficient has to be negative. Right? Okay, so that's easy, I think. Degree. For you to know the degree of this polynomial, you got to look at what? The amount of terms. How many turns did it take, John? John says it took 3. One here, another one here, another one up here. 1, 2, 3 turns. Where do 3 turns come from? 4th degree polynomials, right? 4th degree. Is anybody going to say something else?
Yeah, but and 2.
Or 2.
It says at least, or at least,
It would just be 0.
least possible degree, so wouldn't that be
Or 7.
2 or 0?
7 minus 1 is 6. 6, 4, 2, 0. This is a 3.
Would it be?
0?
What? You guys, here's the deal. 4th degrees, 4 minus 1 is 3 terms. Okay, do a 6th degree. 6th degree polynomial. It will turn 5,
3 or 1.
3 or 1. This is a 3. So this could be a 5th degree. It could be a 7th degree. It could be a 9th degree. But the question, what they say, give me the least possible degree. So all you have to do is take your turns and add 1. And you got it. Now some people would kind of argue with me and they say, well, it could be 4th, but it could be 6th. Yeah, it could be 8th. Yeah.
It says least.
But it says least. That's why I don't want you to get confused. It says least. Okay? Just add 1 to your turns. You got it. Okay, next. Look at this one. LC. Maddie, any idea on this one? LC? You don't know? Okay. Ethan?
Positive.
He says positive. Okay, here's what I see. Down on the left, up on the right. Look, down on the left, up on the right. Doesn't it look like a line?
Yeah.
Is this line going up or down?
Up.
From left to right, it goes up. To make it go up, it's got to be a positive leading coefficient. Positive. Good?
Yeah.
Degree. Count your turns. Adrian, what you looking down for? You should be looking up here. Isaac, how many turns do I have? 2. Isaac says 2. 1 here for sure. Did you count this as a turn?
No.
No. This is your second turn. You only have 2 turns. 2 turns come from what polynomials?
3rd degree.
3rd degree. Add 1 to get the degree. So it's 3rd. And of course, some people are going to say, well, so is a 5th. A 5th degree could turn twice. Yeah. So could a 7th. So could a 9th. So could an 11th. We're picking the least. Next. LC. LC, Annalise, is what? Positive, she says. Would you guys agree? Up, up. To make a polynomial go up, up, it's got to be positive, yeah? And then the degree. Annalise, finish it.
Second.
She says second. She counts her turns. One turn, add 1, 2. Easy, right?
Yeah.
At least I hope it's easy. Okay.
And angry.
Okay, now, here comes some of the most time-consuming thing you're going to do in chapter 5. I'm sorry, I just got sidetracked here. Hold on, let me see. This is day 2, right?
I believe so, yeah.
I'm going to get going on this. I got to look at your book really quick. That's why I'm kind of getting confused.
Go for it.
Okay,
Yeah,
see this?
go for it.
will you put y equals? Put y equals.
Okay.
It's an equation. It's a polynomial. Y equals negative x cubed plus 2x squared minus x minus 2. It says, what is the graph of this cubic function? So they want you to graph it. Describe the graph by determining the what?
And behavior.
And
Number of turns.
number of turns. Okay. You know why they said that to you? They want you to get some kind of hint. Some kind of hint before you begin this problem. So what is the end behavior?
Well, it's if it's gonna be pointing up, up, down, down, or up, down, or down, up.
Okay, first of all, is it odd or even?
It's
Odd and
negative.
negative. It's odd and negative, act like a line. This way?
Yeah,
Or this way?
That way.
Downhill, because it's negative. So up, down is what the answer is. It's going to go up on the left, down on the right. Then your next hint will be this. How many turns will this thing take? I heard somebody say 2. Is that right? Okay.
How'd you get this?
How to get 2?
Oh, wait.
I took
that's
3,
fine.
the
Okay.
cube. I subtracted 1 to get the 2 terms. But wait a minute. Or,
4, or 6.
no, you're going the wrong way.
0.
Or 0. So here's what your parabola, not parabola, I didn't mean to say this. Here's what your polynomial could look like. Up on the left, down on the right. It could do 2 turns like this. See that?
Mm-hmm.
Or it could do this. It could go up on the left, sort of turn, but not really. That would be how many turns?
0.
0 turns. So you're going to get that look or that look.
Okay.
Now which one? I don't know until you graph it. And here's the bad part. The bad part is you have to make tables. Okay? So, because we don't know what it looks like, so we got to start from
Ew.
scratch. Here we go. The bad part is, because it's a curve, you got to do multiple points. What's a really, really easy number?
0,
0.
0. Put 0 in, see what happens.
Negative 2.
Guys, I have to get rid of this because I have no room to work. 0 goes in.
Wouldn't it be negative 2?
Yeah, this is so easy. I should just probably ask you the answer. Answer's negative 2, right?
Yeah.
Let's do next what? 1.
1.
Yeah, probably a 2. Just trying to stay really close to the origin. Let's do 1.
What did you do?
I'm going to use my parentheses I got away from it. Now I'm going back. Okay. Let's do this together. 1 times 1 times 1
1.
with a negative in front.
Negative 1.
1 times 1,
1.
1 times 2.
2.
2. Minus 1 minus 2. Okay, the 2's do what?
Cancel.
What's the answer?
0.
No,
Negative
1
2.
minus 1, negative 2.
negative 2. Right?
Yeah, sure.
Okay, so you got 0, negative 2. You've got 1, negative 2. So really, right now, what does the graph look like?
Might be the second
A little
one.
tiny line going this way. Just a little, like, horizontal. You know, I think you know this. Monday, did I tell you that polynomials are smooth?
Yeah.
They go up and down. They don't go like this. They don't do this. There's no jags to them. So this is not the true look. It's not going to go from here to here. It will probably go like this, or like this, do something. Now, for you to get 2, put the 2 in here, 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 and work it out. Again, let's do it together. Ready? 2 times 2 times 2. 8 with a negative in front. Negative 8. 2 times 2
4.
times 2. 8. What happens to the 8s?
Cancel.
Okay. Negative 2 followed by negative 2.
Negative 4.
Okay. So 2 negative 4 is here. Okay. Now, here's what you should know this. Look, this is kind of what it looks like to you right now. But what you guys should know is the end behavior. What's the end behavior?
Down,
No, it wasn't.
It's up, down.
Oh, up, down.
Wasn't it a line going down?
Yeah.
So you guys should know this. This thing goes like this. It goes like this. And you also should know it's not jagged. It's not going to do this. It's not going to go like this. Boom, boom, boom. It doesn't go, there's no sharp corners. So you should know right in between those two, it's going to do what? Is it going to go like this, dip down and up, or is it going to go like this?
That.
You think it's going this way?
Down.
It's smooth. It's smooth. Okay, it's going to do this. It's going to hit that point, come down, and there is your turn, and there's your other turn. But the question becomes, how far down do I go?
What's it?
I don't know until you plug something in. What's the number? What's the number you should probably plug in to get
3 at this point.
to get how far down you're going to go?
Oh.
What's the x value that's going to give you the y value? What? Half, right? Guys, if you plug in 0.5 right here, it will tell you how far down to go or up to go. But and believe me, it's a down. You're gonna go down further. So put that in, see what happens. Put in 0.5.
How did you get to 0.5?
Well, because Ethan, I looked at the graph. I looked at the graph and I tried 0. And I tried 1 to get that point and that
Okay,
point.
okay.
So really, 0.5 is dead center.
Okay.
I mean, I could have done 0.4 if you want
No.
me to. Okay, 0.5, 0.5, 0.5. And I recommend a calculator on this one, so
Hold
I wouldn't be doing this in my head.
Yeah, 105.
2-second pencil.
If I go down to 45.
We're doing what?
Calculator.
That's wrong.
Question, come on. Quit talking, just punch it in. Branson, what'd you get? Huh? Nothing? Gavin, what'd you get? You got a calculator right in front of you.
I actually take it off the different parentheses.
Dave, are you there yet?
Negative 2.125.
0.125 is not right.
Negative 2.125.
Negative 2 point what?
125.
125. Okay, which, hey, you guys, at 0 you get negative 2, at 1 you get negative 2, but at 0.5 you get negative 2.125. Just a little less. So you would be just down a little further, not much. But do you guys see right now that there's a turn and a turn?
Mm-hmm.
There it is, it's a turn and a turn. So there's your graph. You had how many turns? 2 turns. So it says how many turns? Well, 2 turns. It turned once here. It turned twice here. There's your 2 turns right there. And it did it really quick. It hit that negative 2, then it went to negative 2.1, and then back to negative 2. So it went down, up, and down again. Okay, so it is 2 turns, not 0. Okay? This is the harder one. The next one is not quite as hard. Okay, try this one.
Oh,
Okay, talk about the end behavior. Sean, what's the end behavior? Say again, Sean. You don't know? Okay. Taylor, what's the end behavior?
Down, up.
Down, up. He says it's a down on the left, up on the right. Is he right?
Yeah.
Okay, this is odd. Odd functions act like this. Lines. This way or this way? How are you gonna know? The leading coefficient is what? Positive. A positive leading coefficient means your line goes up. This is a line going up. This is a line going down. Okay, see, he's right. Taylor, you got that right. Now, Taylor, talk about the terms. How many turns could it take?
2 or 0.
He says turns. It could be 2 or it could be 0. Okay, he's right. Because 3 minus 1 is 2. Odd functions will turn even number of times, 2 or 0. Got it. We're done. Well, no, our hint is done. Which means, again, it's going to go like this. This and this. This is what it's going to look like. And it could turn what? Twice. It could turn what?
None.
None. It could go like this, and then it could just keep going. It's one or the other. You have to make a table. Here's your table. And I know you won't skip that number or probably that number. This is actually a really simple polynomial. It's x cubed minus 1. So when you put in 0, it's x cubed. Take away 1.
Negative 1.
0, negative 1's here. Okay, let's put in 1. 1 cubed. Take away 1.
0.
Is everybody okay if I don't show my work? 0. Okay. Now these are the two easy ones. They get a little harder. If you put a 2 in,
7.
2 cubed, take away 1. That's 8. Take away 1, 7.
Okay, you can do that.
Now, be careful when you start doing the negatives. 1027 is, I think, here. There's my graph so far. When you try negative 1, what happens? Negative 1, cube it, take away 1. Negative 1 times negative 1 times negative 1.
Negative.
Negative 1. So it's negative 1 and another negative 1.
Negative.
Negative 2, which is right here.
Yes.
Okay.
So far.
Anybody guessing this? You think it's going to do this?
No.
No.
Okay, you think it's just going to keep going down?
Yeah.
Yeah.
Okay, let's keep trying. Put a negative 2 in. Cube it, take away 1. Negative 8, take away 1. Negative 9. Oh, so that's down here. So it's going like this, 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 and then it shoots. And you could, if you want, you could try more numbers. It's just going to go faster and faster down, and faster up. How many times did this thing turn?
None.
Yeah, there's no turns. Okay, and how do you know? Just jump on the graph. Look, up, 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 up. Slowing down, up, up, up. Speeding up, 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 up. Never went down, or never went up, whichever way you went.
How do you know when to use 0.5 or like a point number?
Okay. So here's the deal. This is why I told you that. I told you that because here's you were coming from here, then you went to here, then your next point was right here. Okay, guys, he's asking me this. How did I know to try 0.5? Because I tried 0, I got negative 2. I tried 1, I got negative 2. You will never see polynomials go down, 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 hit a point, and then make a sharp corner and take off this way. They don't make that kind. They're smooth. All the valleys and the peaks are all smooth. So I knew it was probably going to go, down a little further and up. So what's right in between 0 and 1? 0.5.
Okay.
Now I could have tried 0.6, 0.7, but why would I? Why not do the middle? Okay, and then it gives you a little lower. There's your turn. There's your turn, and your next point was down here.
Mm-hmm.
There it is. And you are not going to do this. Don't go like this. Don't go here to here, here to here, here to here, here to here. It's not jagged. There's no jagged part of these graphs, okay? All right, next. Hopefully you are okay. You okay?
Yeah.
The last graph had how many turns? I forgot to ask.
None.
None. There were no turns, okay? Okay, the last part of your lesson is this. You are just being asked to look at a table. Tell me if this is a table of values that happens to be linear, quadratic, cubic, quartic, or what would be the next one? Quintic. Okay, well how do you do this? How do you know if this is a cubic polynomial or a quartic? Well, up here it says using what?
Different.
Differences. Now, plain and simple, this is all it is. This is so simple. You go like this. You just don't even look at the x's.
Okay.
You don't look at the x's. You take all your y's, you put them down on paper horizontally, and they did a nice job for you. They put them in boxes for you. These are all your what values? These are all your y values. That's all you care about. What do you do with your y values? You do this word.
Differences.
What's the difference between 23 and negative 16?
Apparently 39.
What does difference mean?
Subtraction.
Yeah. You want to do this now. Put a minus sign in between all the numbers. So what you do is you take all your y's and you just subtract the y's. So it's 23, subtract negative 16, which is really 23 what? Plus 16, which is what? 39. Whenever you get an answer, please believe me, if you don't do this, you will mess up. When you get an answer, circle it or box it in like they did for you. You should be, circle your 39. Okay, next up, negative 16 minus negative 15 would be negative 16 plus 15, which is negative 1. You see where they're getting these answers? Okay? Now it's negative 15 minus 10, which is really negative 15 plus 10, which is negative 5. Okay, finish the last three, and then I'll tell you what you're really doing. What was the last one?
41.
Negative 41. So guys, you subtracted all your y's, and if you would have came up with the same number every time, 2, 2, 2, 2, 2, 2, 2, then this is a first degree polynomial. It's known as linear. Are they all the same?
No.
Not even close. It's not linear. Okay. Well, guess what? Is it quadratic? You got to do it again. You got to subtract. And see, eventually, you get down to very, very few numbers. And it gets smaller, smaller every time you do it. So now you got to subtract again. Put a minus sign in between every one of them. Minus, minus, minus. And this is why you want them circled, because you want to know what number minus the next number. So this is 39 minus 1.
So 40.
40. Negative 1 minus 5. 4. Negative 5 minus 3.
8.
Negative what?
2. Negative 2.
8.
Oh, wait.
No. Ethan?
Oh, okay.
Negative 5
Yeah.
and negative 3 together make negative 8. Okay?
Okay.
Next, 3 minus 1. 4. Negative 1 minus 41. 40. Yep. I'm done. Are they all the same?
No.
Not even close. It's not quadratic.
Probably.
Okay. Quadratic's off the board. Yep. Now we're checking for what? Cubic. With a minus here, and a minus here, and a minus here, and a minus here. Here we go. 40 minus 4. 36. 4 minus 8.
4 plus 2.
Negative 8 minus 4.
Guys, that's 4 plus 8.
12.
12. Okay, negative 8 and a negative 4. Negative 12. Okay, and 4 minus 40.
Negative 36.
Negative 36. Are they all the same?
No.
No. Not cubic.
I want the guess of the answer for the last.
Okay, and the last one is, subtract again, 36. Take away 12. 24. 12. Subtract negative 12.
24.
24. Negative 12. Subtract negative 36.
24.
Okay, you finally got it. You got the same number 3 times in a row. It is what? It is quartic. Here's the question. The degree of the polynomial is? Quartic is what? 4th degree. It's quartic, right?
Yeah.
Quintic. Quintic is 5th.
Well, yeah. Oh.
It goes linear, quadratic, cubic, quartic, and then quintic. Hey, we didn't even have to try for quintic because we got it on quartic. It's a quartic polynomial. This table, if I graphed it, would be quartic. Which means to me, quartic just means 4th degree. It's going to be what? Up, upwards, down, down. Quartic could turn how many times? 3. 1, 2, 3. Okay? I mean, that's all I really know today. Okay? All right.
So you
One last problem.
You don't add one, like, or subtract one, like you usually do.
Yeah.
So if you land on 40, it's 40.
Yes, yes. Oh, I see what
Like,
you're
if you
saying.
land on
No,
40,
no.
it's 40, it's not
The first time you did it, you were checking for linear.
Yeah.
Quadratic, cubic. The 4th time you're doing it, you're saying, is it quartic? Yeah. But see, what you're doing, when you start talking add 1,
Yeah.
that's talking about how many terms it can
Oh.
take. I wasn't asking how many terms. I was just saying, is it quartic? Yeah. Okay, last one. Do it on your own. They are not that nice to you this time. They don't write any words down. They don't put any boxes down. You're on your own. That's how I'd start, right there. Yep. I thought you did, but period 5 was telling me you did. Just take it anyways. I don't know. I'm not sure why you wouldn't be graphing here. Nope. The first time I did it, I got this. I'm checking for linear. Is it linear?
No.
No.
No, man, the numbers are not even close. Guys, once you do it first time, it's linear. It's not. Now we're trying it again. It's gonna be, is it quadratic? If I'm doing something wrong up here, would you let me know? Because I'm doing this in my head pretty quick. Is that what you guys are getting on this second try?
Yeah.
Okay. So then, if it doesn't come out to be the same, it's not what? It's not.
Quadratic.
It's not quadratic. So it's not quadratic. Cross it out. Put a minus in between. Every one of them. Minus, 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 minus. Negative 6 minus 0.
Negative 6.
0 minus 6.
Negative 6.
6 minus 12.
Negative 6.
12 minus 18.
Negative 6.
Hey, they're all the same. You're going to say it's what?
Cubic.
Cubic. Which means, whoops, that's a funny C. Which means it's what degree?
Third.
It's a third degree cubic function. Because it happened on the third try. If not, you keep going. Is it quartic? If not, you keep going. Is it quintic?
What happens if it's not clean?
It will be. It will be one of those first 5. Okay. Usually it happens on the third or fourth try. Okay. Sometimes you get lucky. It happens on the second try. If you want this, this would be the last problem for people retaking the test last week. If you want this before you leave, take it. Answer key is here, so you can look at it tonight, tomorrow night, Monday. Let's retake the test tomorrow night or Monday night. Have you looked at Power School? Because if your first test was bad, you should be retaking this. If your second test was bad, you should be retaking this.
Yeah, well, I was just
Oh, you know what I need to know? I need to know if you need graph paper because period 5 said you didn't even need graph paper. You might want to just take a sheet of graph paper because what if you need it?
I gotta see them.
They were wrong.
Well, I haven't seen
I
them.
think you do need it though.
I didn't.
maybe you're thinking of Thursday.
I don't know. I don't know what I'm thinking.
Taylor, you need graph paper?
I don't think so.
Grab graph paper.
I mean, I have graph.
No, I was just saying, don't do whatever Taylor says.
That's true.
Whatever you say to the opposite of.
Yeah, that's true.
You can jump off that bridge quickly.
Oh.
Before you die. You're gonna do something.
Yeah, I know.
I don't think you need graph paper. Now that I look at it. No, we grabbed your notes. Is this the white? Not the purple. You done? You need the white answer key 4647, right?
Yeah.
You want to take a picture of that? You ready to do this? Oh. So we're done there, we're done here. Just look back for me, please, if you want that.
These are my late work.
Okay. 1 second, Molly. Okay, boom.